All right, so I had a request to go over some of this homework, how it works, and I will do that this way. So you should remember with this first question where what the different colors are basically. So that this part up here should be red, and this one is yellow, and this one is blue, right? And that's the red is flammability, the blue is health, and the yellow is reactivity. And the same is true for substance B. So which substance is more flammable? You're looking at the red ones, the difference between here and here. And you can see that substance A has a higher number, so that would be substance A. Which substance is more toxic? Toxic meaning bad for your health, so you're looking at blue. And so maybe that will work. Look at that. Nope, that's purple. Anyway, so blue there is higher than the blue there, so that would be substance B. Which substance is more unstable? That is where you're looking at reactivity, which is yellow, so you're comparing the 1 to the 2, and so therefore substance B would be more unstable. And which substance should be kept away from water? That's what that W with the line means. So that would be substance A. That's a stupid pen to use. Substance A. All right. So that's how that works. Fill this one out. So same thing. Your health hazard is a 2, so that should be blue. And then that would go here is where the health goes. Your fire hazard should be red, and that's the top one. And your reactivity hazard should be yellow, and that is here. All right, so moving on. These are pretty much just from the notes in class. This yellow one means radioactive. You just have to be able to recognize this as long-term health effects. This one is corrosive. This one is bioterrorism, biohazard, and that's explosive. All right, so in gym classes, do students perform better academically in elementary school? So your independent variable in this case, let's actually get a color here. Let's go with blue, I guess. So your independent variable would be kids with and without gym class. And then your dependent would be how they perform academically, right? Performance in school would be that. And then as far as your constants, your constant variables would be what classes the kids were taking, what they did in gym, how old they were. So the things that you want to make sure aren't, the male female ratio, that kind of stuff, things that aren't going to affect the outcome, so that the only thing you can point to as being the reason for the outcome is whether or not they have gym. That's the goal, at least, of keeping things constant. All right, so does feeding your dog wet food control weight better than feeding dry food? So your independent in that case would be the dry versus wet, right? You can have a group with dry food and a group with wet food. And then your dependent is going to be their weight control. And then your constants in that case would be the type of dog, right? The type of wet food, the type of dry food, the serving sizes you give them, how often you feed them, the exercise they get. Otherwise, you want to make sure all that's the same regardless, so that the reason one is having weight control over the other is because of the dry versus wet, and not because they're exercising more or one group's younger than the other or something like that. So for this one, you just want to graph this data on here, and they jump so this would all be on your X. So you would have 0 and then 0.0001, right? Nope. And then we'll do it like every 2. So that's 0.01, and that's 0.1, and that's 1, 10, 100, and 1,000. There you go. And then, so then you graph all this, and you'll see that it's it's 0 for that one, and it's 0 for the 0.01, and then the 0.1 goes up to 10. So I guess we got to make some of this work. So we can do like 10. This isn't going to really work. 30, 40, 50. Although if I were better at doing this, 60, 70, 80, 90. That should be 80. And then 100 should have been a little higher. All right, so then 0.1 would be 10, and 1 is 30, and then 10 is 50. 10 is 50, so there it is. And then 100 is 70. So you do this, and then 1,000, I guess, is what that is. And that's 100, so that would be off here. That would be up here. All right. So you do this, and you get this draft, this sort of S shape like we were talking about. And then the rest would go like that as well. And the LD50 is where 50% would die. So you can do it by the graph, or you can just see that there's a 50 here. So, whoops, wow, that moves. Why does that move? All right, anyway. So the LD50 would be 10 mgs per kilogram. That would be the dose that kills half of them. And the lowest dose response, so the lowest response, so the thing that actually had a response was at 0.1 mg per kg. Right, I think that's what they are. Yeah, and then 10,000 would also have 100% deaths, because 1,000 had 100% deaths. And they didn't include it because after you kind of kill everything, you assume more will just kill everything as well. All right, and then for this chemical physical change, if it's reversible or it doesn't really change the substance's properties that much, then it's a physical change. If it's chemical change, then something really happens chemically to the... And like I said, this isn't something I love to do because it really involves you knowing stuff that you don't understand yet. But evaporating would be a physical change. That's a phase change. Salt dissolving in water is something of a trick question, but you can get it back if you evaporate the water. You can get the salt back. So that's a physical change. Iron rusts is a chemical change. You can't really go backwards unless you add chemicals. Bronze metal sculpted, you're just cutting the bronze, so that's physical. Gold is melted, that's just physical. It's still gold. Ice melting is still physical. Milk sours, that's chemical. If you could unsour milk, you wouldn't throw it away. And frying an egg is a famous one for chemical, even though it's the one that drove me nuts, because you can't unfry an egg. Now, compound is homogeneous or heterogeneous. Compounds will have the same ratio no matter where you have them. So when you have things with chemical equations, that's going to be a compound. Mixtures, being homo or heterogeneous, just means, are you going to see interfaces or borders between the multiple things, the mixture of things in there. So soda with bubbles, you'll see a border between the bubbles and the soda. So that's going to be hetero. Ocean sand with shells and such, that's going to be hetero, because you can kind of see where one begins and one ends. Salad dressing, again, it's assumed you're going to see some herbs in there and whatnot. Kool-Aid, no ice, just clear. That's trying to tell you it's homogeneous. You can't tell where the sugar ends and the water begins. Brass is a mixture, it turns out, and it's homogeneous. You can't see where the copper ends and the iron begins or whatever. And clear chicken broth, I was going for homo, but if you put hetero, with hindsight, that's fine. Now these are like what we did on the quiz. So anything that has a formula is going to be always the same, so therefore not a mixture. It's going to be a compound, and now you got to figure out whether that compound is ionic, which is a metal and a non-metal, or covalent. So you're going to use the periodic table, and remember, on the periodic table there's that staircase up in the corner where all these are metals and all these are non-metals, and the metalloids touch the staircase. So ethanol, carbon, hydrogen, oxygen, they're all non-metals, so that's going to be covalent. Neon is a non-metal, that's an element. Calcium chloride, calcium is on the metal side, chloride's on the non-metal side, so that's going to be ionic. Ammonia, N and H are both non-metals, even though H is over here, it kind of belongs over there for metal characteristics because it's a gas, it's a non-metal, so that would be covalent. Copper is an element and it's a metal. Potassium phosphate has potassium, which is a metal, and phosphorus and oxygen, which are nonmetals, so that's ionic. Iron oxide has a metal and a nonmetal, so that's ionic. Silicon is a metalloid because it's on the staircase. It's surrounded by that staircase. Aspirin, all nonmetals, C, H's, and O's, so that's covalent. Acetic acid, HCs, H's, and O's are all covalent. Sodium bicarbonate is ionic. Aluminum is a metal. Ozone is a compound, oddly enough, because there's more than one atom there, and that is also a covalent compound because oxygen is a nonmetal, and lithium is a metal, nitrogen is a non, oxygen is a non, so that's ionic. All right, and then these you're just going to add 273 to the Celsius to get the Kelvin, so that would be 323. And if it's in Kelvin, you're going to need to subtract 273 to get the Celsius. So that one would be 152 degrees Celsius. So you should be able to do that for the rest of them. And then you have to put both these in the same thing to see which one's moving around more. Remember when we did the FET, the things would move around the more they had going on. So 100 degrees would be 373 Kelvin. And when you compare that to 230, this would be the one moving around more. And then this last one is just a matter of putting into place which of these things go where. So definite shape. Only solids have definite shape, so you would only put that there. Melting is the difference between a liquid and a solid, so you would put melting here. What number did I give melting to? So that would be a 2 would go there, and then freezing is liquid to solid as well, so that would be a 3. It would go between the liquid and solid. Deposition is when you turn gas to solid, right? It's going that way, I'm pretty sure. The other one is sublimation, I think, is when solid turns right to gas. So 4 would go there. 5, definite shape, which we already said was a solid. 6, sublimation, would be between solid and gas as well. 7, evaporation happens between liquid and gas, so that would be 7 there. All right, and that's how you do those. And then the lab. So that should do it. Hopefully that is helpful if you are struggling with this.